So, today we're going to talk about the arithmetic series. And first, we want to talk about what is a series. This is where vocabulary is going to become important. What is the difference between a sequence and a series? A sequence, we said, was just a list of numbers that followed a pattern. A series is still a list of numbers that follow a pattern, but we want to add them up. So, you're adding up all of the numbers instead of just listing them. All right? So very small difference, but the words do mean something different. So a sequence is a list of pattern numbers. A series is the sum of those numbers. So, example, 2, 4, 6, 8. Who do we appreciate? This would be a sequence. It is a list of pattern numbers. All right? 2 plus 4 plus 6 plus 8. All right? It's still the same list of numbers. They still follow the same pattern, but this time we are adding them all up. That would be a series. All right, so that's the difference between a sequence and a series. Now, there are two types of series and sequences, for that matter: finite and infinite. This is where we want to use some of our vocabulary skills. All right, finite, to finish. All right, a finite sequence or series has an ending. It starts, it ends. It's a set number of terms. An infinite sequence or series continues on forever. The key there really is ... Does it keep on going? All right? So let's look at a couple of things compared to each other. Finite versus infinite. So here we have a finite sequence, 6, 9, 12, 15, 18. It stops. It has 5 terms. We know exactly what's in there. An infinite sequence, same pattern, 6, 9, 12, 15, 18, ... It keeps on going. Those numbers are never going to stop. We're going to keep adding 3, adding 3, adding 3 over and over and over and over and over again. It's never going to stop. Same thing with a series. Finite series, 6 plus 9 plus 12 plus 15 plus 18, and it stops. Whereas an infinite series has the plus ... That means it's going to keep on continuing on forever and ever and ever. It's not going to stop. Excuse me. All right, so let's talk about specifically the arithmetic series. Now, we've done arithmetic sequences and geometric sequences. All an arithmetic series is the sum of an arithmetic sequence. So the numbers still follow that arithmetic pattern. If you just look at the list of numbers, it should be an arithmetic sequence. Again, the difference with the series is we're adding all those numbers up. All right? So we are looking at, it's still an arithmetic sequence, it's just got plus signs now instead of commas. All right? Now, when we are trying to find the sum of an arithmetic series, it is very important to note, I've got to go back for a second. All right? That there is a difference between finite and infinite. In an arithmetic series, it continues on and on. If we're adding 5, each number is going to be 5 bigger than the number before it, and it's going to continue on in that pattern. So we cannot find the sum of an infinite arithmetic series. If it goes on and on and on and on and on and on forever, it's just going to keep getting bigger, or smaller if it's negative, but it's never going to actually have a sum. It's not going to stop. All right? Finite, however, if it's only got 10 terms, well, I can take those 10 numbers and add them up. If it's got 100 terms, I can take those 100 numbers and I can add them up. Even if it's got 1,000,000 terms, I could take those 1,000,000 numbers and I could add them up. I can get a sum. So if it's finite, it does have a sum. If it's infinite, it does not have a sum. Now, the other problem is, adding up 10 numbers, okay, I can do that on my calculator. That's not a problem. Adding up 100 numbers, I do not want to do that on my calculator. Adding up a million numbers, I'm definitely not going to do that on my calculator. So we do have a formula that helps us find the sum of an arithmetic series. Now, this formula only works for arithmetic. If it is not arithmetic, you cannot use this formula. We do want to make sure we know what all these things stand for in the formula. So things to remember. N is still equal to the number of terms. That's not changing. A1 is still equal to the first term. S represents the sum. Now, the sum of so many terms. So if it's the 10th, we're trying to find the sum of the first 10 terms, then S10. A sub n is representing the last term in that series. Again, if we're finding the sum of the first 100 terms, then it would be A100. What is the last term? If we're finding the sum of the first million terms, it would be A1 million. What's that 1/1,000,000th term? What is the last term? So we have our first term, our last term. How many terms do we have total? All divided by dos, 2. And so this is our formula. So let's look at an example. All right. So if I have 2 plus 11 plus 20 plus 29 plus 38 plus 47, let's look and see if it's arithmetic. 2 plus 11 is 9, so it's 9 plus 9 plus 9. Yes, okay. So it's adding 9 each time. It is arithmetic. So we could use our arithmetic formula. So S is equal to n times A1 plus AN all over 2. Now, you may be asking, Ms. Parker, there's just 6 numbers there. Why can't I just add those 6 numbers on my calculator? And the answer to that question is you can just add those 6 numbers on your calculator. However, I do want to show you how the formula works, because when we get to ones that we're trying to find the sum of the first 20 or 50, I do not want to type those in my calculator. So I will go ahead and say it is 6 numbers. You can just type it in your calculator. Double check my answer. Make sure I get it right. All right, so looking at this particular list, I need some things. I need the first term, I need the last term, and I need to know how many terms there are. So let's count. 1, 2, 3, 4, 5, 6. There are 6 terms. So n is equal to 6. What's the first term? 2. What's the last term? 47. And then I got to divide everything by 2. So 6 divided by 2 is 3. 2 plus 47 is 49. And 3 times 49 is equal to 147. So the sum of those 6 numbers is 147.